I'm cat neutral.
Cat neutral.
Yeah, so I work on a project called DAT. It's a cool open source project that's independently funded by grants, which means that we get paid by non-profits and basically by writing grant proposals. So the goal of the project is basically to create creating JavaScript tools, open source JavaScript tools for reproducible science, which is like a totally generic, broad term. But basically, let's say I write a paper that analyzes some data. You want to write tools that allows you to basically get the data you put in a paper and being able to reproduce the results you get in a paper. And we mostly do JavaScript, and we have currently written more than 750 modules on NPM, which is pretty fun. Fun fact, there are around 200,000 modules on NPM, so we have around 0.5% of every NPM. So if you install more than 200 modules, there's a good chance you get one of ours, which means that we can clone anybody in here by putting bad code in there.
22K at the moment.
22K?
22.
Shit.
2200.
Wow.
220. Never mind. I can't numbers like no. That's not my stuff.
220,000.
1,000, yeah. Yeah.
Yeah, big number. It used to be 100,000 not that long ago.
Yeah.
So our tools are mostly targeted towards civic hackers, so people who work with various open data sets published by governments, data journalists, and data scientists. And like I said, our main goal is creating tools for scientific data reproducibility. This is actually what we're funded to do in our grants, but it's also generic enough that we can do other stuff. That's fun. So this is kind of like our goal, I think. Overall, we're just trying to make something that's similar to peer-to-peer Dropbox for datasets. So if you ever used Dropbox, it's pretty nice because it's very simple. It's just like a folder, and you drop something in there, and whoever else you know who has that same Dropbox get those files. It's pretty nice. We want to do something that has like the same kind of UX simplicity, but for datasets. And datasets could be a bunch of CSV files or a bunch of pictures or like some sort of structured data that doesn't necessarily fit into a file format. So this is something that is being talked about a lot in data science. So basically you have kind of like two schools. So let's say you have a data set and you wanted to do some analysis on it, right? So the old school way of thinking is you take your analysis or your code and you move it to the data because your data is huge. So that, another way of thinking about that would be, let's say you had like a terabyte data set. And that's so big that you cannot really download it, it's on a server. So you would write a program that would analyze this data, you would copy this program to the server and you would run it, kind of like a classic mainframe kind of thing. Which is fine, except that it's introducing all these central points of failures. It means that we have to book time on a supercomputer to run stuff, and it's just kind of like that. So we want to basically try to flip this around, and instead of moving code to the data, we want to move data to the code, meaning that you want to get the data to your computer and then you can run stuff on your computer. So we have 3 rules that we try to live by in a sense. So first is, since we want to deal with big data sets, only download what you need. So if you have that terabyte data set, it might be that your data analysis only touches like a megabyte of it. So that means that you shouldn't download that entire terabyte. You should only download that 1 megabyte. Whenever you download something, you should share it. So if I downloaded a megabyte of that terabyte data set and Firas was interested in the same megabyte, you shouldn't necessarily have to get it from the same source. You could just get it from me using some peer-to-peer protocol. that allows nice distributions of data and kind of removes a lot of cost from these central points that's out there. And if point 1 or 2 is not good enough for you, like there are still analyses that require you to look at all the data, then it's fine to go back to the old ways of doing it and actually move your code to the data. So that's kind of like online stuff. This is a kind of fun example of why this is totally broken today. We tried to do stuff with Wikipedia, and the first thing you need to do if you wanted to do some data analysis on Wikipedia is actually download Wikipedia. And Wikipedia is a non-profit, and they actually expose their entire data set. But you're limited to 2 connections per IP, and both of these connections download really slowly. And at home, I have a pretty beefy internet connection, and I wanted to download and help sharing it. And I think it took a week to download or something like that, which basically means that at the point in time where you download Wikipedia, it's already out of date because Wikipedia updates all the time, and then you can kind of restart. And they only allow you to download Wikipedia from a central server, which is why it's slow, because it's probably cost them a lot of money if it was just super fast. There's no peer-to-peer solutions. There is an unofficial torrent that somebody publishes that's always out of date. So it's pretty bad. Here's another crazy example of something that's really, really terrible. So Bruno, a guy we're working with who does a lot of bioinformatics. So that's bioinformatics, basically research into genome data, so like the Human Genome Project, stuff like that. It's basically a bunch of really, really smart people working at a university in London, and he wrote this really cool blog post called "When Bioinformatics Break" about the fact that what really was really hard for them was that they wrote a bunch of tools analyzing genomic data and did some very groundbreaking research into genomic data, but it kept breaking all the time because somebody was breaking their APIs. Like all the data was hosted in a central location, and somebody who was maintaining that central location thought it was a good idea to always like tweak that API a little bit, make it better, and would just end up breaking their things all the time. Which means you have you're doing like groundbreaking genomic data, but just coding against a moving software target, which is like a really, really bad combo. So kind of broke reproducibility for them all the time. Another crazy example, this is another project we work with called, I can't remember the name of it, but it's the Trillium Project. It's basically a project where a bunch of scientists were scanning the sky, or a very small piece of the sky, space, to do some analysis on it. And as you can probably imagine, that results in a lot of data because space is pretty big. And they would put all this data on an FTP server. And it's like literally terabytes of data. And the smallest possible block you can get to download it, because they knew that you wouldn't want to download like a terabyte of data all the time. It's like 10 gigs, but like that's their block size, which is still pretty big. And it's all these weird files, and it's all these proprietary formats. So, which basically meant that there was a huge effort into scanning the sky, but it's really, really hard to do anything with the data because nobody could get it except some very few specific people who actually knew what they were doing. So what we want to do is we want to take data and we want to move it from this centralized solutions and move it more into like possibly a decentralized solution, or even better, like a distributed one where everybody helps share data sets and we can all fix this, hopefully. So, for us, are you ready?
Yeah, sure.
So, before I go into more details about how we're doing it, I work a lot with for us, and we've been doing a lot of fun stuff with data distributions. A really cool way of distributing data, as you probably know, is BitTorrent, which we're hugely inspired of. So I asked for us if you wanted to help out and show how you can also do this in JavaScript using something called WebTorrent, which is also based on BitTorrent. Yeah? Want to get into the cable?
Yeah, sure. so I think that kind of the reason why we want to show WebTorrent is just because so some of the stuff that Matthias is going to talk about later with DAT is about how the DAT protocol uses some of the ideas from BitTorrent for file transfer. And so how many of you guys know about how BitTorrent works? Okay, like have you guys ever read any like specs for it or kind of like lower level like how it works? Okay, a few people have. Okay, cool. Yeah, so one of the things that is pretty cool about doing having a BitTorrent client that's implemented in JavaScript is that it's really easy to play with, hack on, and like do things with. So you can kind of you have a programmatic BitTorrent client with WebTorrent. So you can kind of write programs that like fetch files over the network and then do something with that data. You can get the files as streams, so you don't need to have the whole file in memory before you can start to operate on it. You can do kind of things where you seek to a certain point in the torrent and access data at a random location. And so you can sort of prioritize the pieces that you need, and then so if you are really smart about, you have some application where you need to be able to seek through the torrent and get different pieces, you can do really clever things. So like one project that Matthias did that was really clever use of this was to take Wikipedia and basically build a Node app. You run the Node app, and it starts a local server on your computer. You visit the URL, and then anytime, so it loads like the Wikipedia homepage. And then anytime you click on an article, it will see that request is coming in for that Wikipedia article, and then it will say, oh, where is this page inside of this giant multi-gigabyte torrent? And then we'll go and fetch just that page. So then the page loads for you. And so it's like almost like an instant browsing experience for Wikipedia, but you don't have to have the whole thing pre-downloaded, right? So as long as so obviously it's outdated because it's a torrent, but it's kind of cool. So what I wanted to show is just a little bit of like how that works, how you can build things like this with the WebTorrent library. Oh yeah, the other thing I didn't mention is that one of the things that makes WebTorrent unique is that it works in the browser as well over WebRTC. So you can do the same techniques for your web apps as well. So let's just like dive right in and see what we can do. So can everybody see this? No. Whoa, this is terrible. Weird. Okay. So what I'm going to do here is create a new file here. We're just going to require WebTorrent, and then we're going to create a client. This is how you initialize the torrent client. You can have many in one program, but we just need one here. And then to download something, we just do client dot. Well, actually, first we should probably seed something, right? So we have something we can download. So we call client.seed. And we pass in, we can pass in a path to a file in our system. We can pass in a buffer of data. We can pass in whatever, like many different types of files. But what I have here is a WAV file that I'm just going to pass in. So file.wav, it's a simple little 10-second file. And then we get this callback with the torrent object once the file has been announced to various trackers and to the DHT, which is the decentralized way of finding peers in BitTorrent. So once I get this callback, I'm going to log out the torrent file's magnet link, and maybe, yeah, I guess that's good enough. Let's just log out the magnet link once we have started seeding it. So now I'm going to run that. Oh, oops, it's called download. Oops, let me put it into this file. See it. Okay. So I'm going to run this program. And actually, let me run it with debug logs on so you guys can see that it's doing a bunch of crap. Yeah. so you can see here it's like traversing the BitTorrent DHT. It's finding the appropriate nodes in the DHT, which should be notified of the fact that we are now seeding this content. And once it finds them, it tells them like, hey, like this is my IP, this is my port. If anybody comes asking for this torrent, like here's the person you should connect to who has it. And let's see, okay. maybe this was a bad idea because now I can't see the log that I want. Actually, I can search for magnet colon, can't I? Yeah, there it is. Okay, so see this right here? This is the magnet link that we can then use to download this, this content. Now, I could paste this into a typical client, but let's actually just write a client ourselves. So this is a separate file now. I'm gonna, again, require WebTorrent, create a client, and then now we're gonna just call client.download, and we're gonna pass in the magnet link. Did I do this right? Okay, cool. And then magnet URI, and then we're going to get a callback with the torrent once we. So what happens is, yeah, this gets called when we have metadata about the torrent. So the metadata is various things, but mainly one thing that's really interesting to log out is probably just the list of files. Maybe we should map over that, and for each file, we should print out the file's name. And then, how about? So we know that this torrent is going to have one file, right? Because it's just the WAV file that we're seeding. So how about we just go in and we get that one file out, torrent.files0, and then for that file, let's. Well, what should we do with it? How about we pipe it? So we create a stream out of it. Are you guys familiar with node streams? Okay, so a node stream is basically just a way to get to take some sort of source of data and then progressively access the data from that source. So you could use it for like reading a file off of your disk, and the file's too big to fit in memory, and you want to be able to like get the data sequentially and process it or something like that. So we're going to create a stream on this file, and then we can pipe it to a source, to a destination that's going to do something with the data. And since this is an audio file, we should probably try to play it. So there's a node module for that called speaker. It's really handy. So the speaker is the destination of the data. So we can require speaker, and then just pipe into the speaker. Does that make sense? Okay, cool. So now let's try running and see if my code is broken. Okay, node download. So it works. And we can see here also logged out the list of files in the torrent. Cool, so this is a programmatic torrent client you can build stuff like this with. And I have one more thing I want to show you, which is it working with the browser. So, all this stuff, all this code that we wrote works exactly the same in the browser, with the one exception of the code we wrote that seeds from the file system. Obviously, we can't access the file system in the browser. So we can do things like, instead, we can maybe get the file that the user wants to seed via drag and drop or something like that. But so what I'm going to do now is I'm going to take that code that was seeding before, and instead of starting it up in Node, I'm going to start it up in this thing called Electron. How many people have heard of Electron? Okay, so Electron is this project from GitHub that is what they use to build the Atom text editor. And it's really just Chromium packaged up into a thing that lets you basically show HTML and CSS and JavaScript to the user and make it look like a native app. But the nice thing is that this JavaScript has access to everything on your computer. It's just like a Node script, right? So it can read your file system, it can open sockets, whatever. And since it's Chromium, it has WebRTC built into it, which is the peer-to-peer, peer-to-peer protocol we use to talk to peers on the web. So if we start that same file that we wrote earlier to seed this file up, but we started in Electron, then we'll be able to download it from the browser. So instead of starting with the node command, we use this command called electron spawn, which just takes the script and opens up a headless Electron instance and then executes the script in that instance. So this is going to read the file off of our file system, and this is just some Chromium spewing. Don't worry about it. It's not actually an error. Yeah. So okay. So now we have. Now we can go and just take that same magnet link that we had from before, and this should work as a download from the browser. So there's this little website here, which is a really good way to test out WebTorrent to download things. You just go here and you can paste in magnet link, and it really just calls the download function that we wrote earlier. It's basically the same thing. So I paste it in, I click download, and it should find the peer, download it, and play it in the browser. Cool. And so this is a WAV file, which unfortunately we can't stream. But if you were to do this with a different file type, like an MP4 file, that was, let's say, a gigabyte, it would actually start to play it before it had the whole file. Just another nice feature that WebTorrent has built into it. So yeah, that's what I wanted to demo.
Oh, cool.
Can I ask a question?
Yeah, sure.
The download speed, is it coming from the WebTorrent server, like the proxy to the BitTorrent network, or it's the download speed between the browser and that proxy that you have?
There's no proxy here. So this browser tab here is talking directly to this program I'm running on my local machine.
Okay, so
There's no intermediary.
So if I was downloading it from the BitTorrent network, would it count as well? I'm just because like if the file was hosted on BitTorrent, right? If you you grab a normal,
He's running a full torrent client in the browser.
yeah, but it's not connected to the BitTorrent network, right? Like
The browser is not connected to typical torrent clients like uTorrent or Transmission or whatever.
yeah, but it can use your WebTorrent proxy to do that, right?
There's no WebTorrent proxy.
Yeah.
There's just there are just BitTorrent clients that can talk WebRTC, and there are BitTorrent clients that can't talk WebRTC.
Oh, I see.
So
I see.
what we have here in running in my terminal is a BitTorrent client that can talk WebRTC,
I see.
as well as TCP and UDP.
Okay.
So this one is when it's seeding the file, it's seeding it to all types of clients,
All the other ones.
WebRTC and TCP ones. So I should be able to take the same magnet link. Actually, I've never tested this yet. I don't know if it'll work, but let me try opening transmission.
Yeah.
Alright, so I should be able to paste this WAV file in,
Yeah.
and it should be able to download.
Yeah, that's true.
I've never tested this because this Electron thing. Hopefully, you can do it.
Looks like it's working on something.
I'll pass the magnet link. Peers.
Metadata means.
Torrent metadata needed.
Yeah, so it's trying to find it in the DHT. It could be just slow because of the network.
Mm-hmm.
Here, let me try this. How about we do node seed, just to make sure this should. So running this seeding. Oh, it found it. Oh shoot! Why did I stop seeding? Oh no! Oh wait, no, not finding it right because
Yeah, you already got it. So now it's
So the browser just can't talk to transmission.
the browser can't talk to transmission. Yeah.
Yeah.
Actually, I have a picture that can explain this better.
It's coming.
Yeah, it's downloading. Okay, cool. Yeah.
yeah, it's sweet.
So, but what I want to show that this picture here will explain kind of the situation. So
Okay.
This
So
is,
what I was saying proxy, I meant like your hybrid clients.
oh, hybrid clients.
Yeah, sorry, I used the wrong word. So like I was trying to understand like if the download speed was actually coming from the hybrid client from the BitTorrent network, or just like the bridge that you have directly from the hybrid client to the WebTorrent client.
From
on
all
the
the peers connected to
from all the peers
browser peers.
That speed is local to the client that you're
to that site, from the
this
hybrid to the okay.
Yeah. So it's literally like this link. It's the link here. This one. This like blue link right here. So this is the browser page. The browser page had a link to the hybrid, the Electron app. And that was
Yeah.
this
Okay.
link.
So that's the speed there. Okay.
Yeah. Cool. Yeah, the hybrid clients don't do don't like go and get things for you. They're not proxies. So the browsers here, they can't be like, oh, go get me this thing, because this person wouldn't be very happy about their torrent client going and downloading random things for random people, right? It's only just once this person has some content, they are seeding to both.
Okay, seeding to both. Okay.
Yeah, cool.
But you are building also that feature, right? Like to have the hybrid
Proxy,
client. No, not at all. Okay.
Yeah, no.
Oh, I had that idea. Sorry. All right. Sweet.
Yeah, can I grab the thing? So, you're probably confused a lot of people now. That's all. So what we're trying to do is take the same techniques as Parash just showed, this also demo, and apply them to generic dataset sharing, right? So instead of streaming WAV files from peers on the internet in the browser, just stream datasets. It's pretty simple. So what we did was we took the BitTorrent protocol and we tweaked it a little bit to kind of fit our use case for open data. So it's like a 95% share protocol almost, probably like 90, and then 10% added cool stuff. Yeah.
Quick question. I don't want to interrupt if you
No, that's fine.
want to explain it later, but can you say mention a few words on how this differs from something like the torrent sync?
Yeah, I think I'll get to that. Otherwise, we can take it afterwards. I might be lying about that. So just some key points here. Oh yeah, Max added like a thing where so you can see the cat. So basically what Firas was talking about, right, was the top thing here, replication, like have a way of getting the data. He was streaming wave files, but we can kind of think about the same thing, but just getting actual data sets. Sharing, Firas was doing that also, being able to share them back. So what we're trying to add to BitTorrent is like version control. So basically being able to get something and get updates to it and trust those updates. Collaboration, so being able to collaborate on torrent, if you can think about it that way. So if I share a data set, but for us, you could update it and share it back to me, and I would only get that data and stuff like that. And the last thing here is also being able to package up entire machines into containers, like our containers, and share them using the same technology. Because if you have all these things, you kind of have almost like a data set machine where you can like run data analysis, package up your code, package up everything, and share that with a paper you're writing, or just for fun, or if you're just doing some analysis. So that's basically the DAT tool, and I can just give a quick demo of that. This stack trace filled tool. So it's both a command line tool and a desktop app. And it's all under development, but it's pretty close to being done. And that's something we always say as developers, but you gotta trust me, it's pretty close to being done. It's been pretty close to being done for like 2-3 months now, but this time so what you get is you get this.
It's pretty close to being done.
That's what he meant.
It's right. Because I swear it worked just before I did this. Let's try this, if this works. Oh yeah, okay. Just a clear mistake. So, with filtering out like the last box. Crossing my fingers. So, what you can do is you can just install it on your command line also. How do I do this? Oops, not like that. So if you install it from npm or using GitHub, you get this tool called DAT. And it's very simple because it only has 2 commands. It has one called share and one called hash. So right now, the only features you can do is you can say DAT share and you can give it a folder. I'm just going to share my usage data here because that's nice and safe. And I get this hash back. And what I can do is, we're working on having also non-hash links, so we can have like a nice username / something link, but that's like the features coming up. But what you can do is you can go into your DAT app, and you can click download. I can paste this link here, and give it a folder. How do I make a new folder in this? I'll just put it in my home. It's probably safe. This is how I delete all my files accidentally during a talk. So let's say it was a data share. That will actually save it and put it in this folder. So hopefully now, if I go to my home folder, I'll have the files of the users folder, which are these 2 files. Let's try to share some pictures also, just for fun. So I think I have to slack cat figures in here. So let's try to see if this works. Not a feeling when hashes look alike, but so I can download this one also. Paste that in. Just put it here also. What could go wrong? Only shows one folder. So as you can see, like downloads all this data into my whole folder here now. And actually, I'm gonna spend like hours cleaning this up. So it's that simple to use, and you're gonna be able to use the desktop app to also share like data sets like that. So that's kind of what I meant, like a Dropbox for data. So something that's that simple to use. And I'm happy to go into more demo details afterwards, but let's just continue this so we can get to the different things between this and other stuff. So yeah, so like I said, it's basically just two commands, share and download, and there's a UI for it also if you don't like command line. Turns out a lot of scientists actually love command line. I had no idea. I guess it's because you can automate things easier. This hash also looks like the other hash. Like all my hashes start with 2.
Well, what size data sets have you tested this with?
So I tested it with pretty big data sets, and there's definitely bottlenecks in there now, but containers, which are gigabytes, still need to test it with like terabyte stuff, but it should work. Like, it should be ready. But that's definitely something we need to have more benchmark on stuff like that. Yeah, so it's all built using Node.js. Node.js is cool because it's basically designed for doing these kind of things. I don't know if that was the purpose of it, but it's really, really good for doing I/O and network, which is why it's really, really good for doing these kind of rituals. It has this notion of everything being a stream. So like a stream in Node is kind of almost what I talked about earlier, where instead of getting everything at once, you just get what you need. It's kind of like a stream. You get like pieces in as you need them. So that's
like
really
a Unix
cool.
pipe.
It's like a Unix pipeline, if you're familiar with that concept. It's super cross-platform. It basically runs on every big OS out there. So like Linux, Mac, Windows, it runs on BSD also, all these kind of things. And you can very easily tweak your code to run in the browser, kind of like for us here with WebTorrent, because it's all JavaScript. So I'm actually also able to run the DAT tools in the browser, so you can theoretically clone a dataset into a website without even installing it, so that's pretty awesome. And using this new thing called Electron, we can package everything up as desktop apps. So that's super cool. And by using something like npm, which is a really cool package manager, for us, since what we're doing is kind of like 90-95% BitTorrent, we're able to share a lot of code, even though we're working on 2 different projects. So that's really cool. So it's a really good platform for doing these kind of things. Bit on the tech here. This is actually a wrong drawing, but I didn't have time to fix it. But this is all based on something called Merkle trees. So that's how we do diffing and syncing. Merkle tree is basically just a fancy way of hashing things. So if you have 2 files, B and C, you can hash file B and hash file C, and you can create kind of like an identifier describing both files by just hashing them again into a tree. And you can continue doing this by just adding more files. So this is really good because if you're familiar with distributed systems, this is a very easy way of diffing 2 datasets and then making sure you only get like the diff you need. So that basically means that I can share something. If I share a file with Faraz, a specific file, and Faraz tries to download a dataset from somebody else that also contains that one file shared with Faraz won't need to download this file again because we use techniques like Merkle trees to diff these kind of things. So that's something that's very different from BitTorrent sync. If you're familiar with how that works, I spent more time than I care to admit doing BitTorrent stuff, and BitTorrent actually is really bad at doing these kind of diffing things because of some stupid mistakes in the protocol. That is, which is not necessarily a bad thing, it's just because it's designed a long time ago, I think, and for a different use case. We use this thing, which is really cool, called repeating fingerprints. So basically, given 2 versions of the files, how do you figure out which part has changed, right? So, how many in here has used Git? Right. So Git is really cool because Git is really good at figuring out what has changed in a file. And Git is really good at figuring it out because it's really easy to do with text files. Because what you do is you just pick a delimiter in a text file that's a new line, because a new line is something we type all the time. And you just split a file into lines, and you just check every line as like an atomic thing. So if I add a line in the middle of a file, all the lines before it will be the same, and all the lines afterwards will be the same. So it's very easy for a computer program to figure out that it should only share that one line, and some metadata saying that you should add these previous lines. It's really, really hard to do this for binary files, it turns out, because we don't have new lines in binary files. If you ever try to add a binary file to Git, you probably notice this, because everything kind of blows up. Not blows up, but just becomes slow, because it's trying to tries to diff it and doesn't really work. So you can use this thing called repeating fingerprint, which is something called content-defined hashing. What Rabin fingerprinting basically does is, I don't completely understand it, I just know it works. It's usually good enough for me. Is that it scans through a file, and it basically does a sliding window hash. So it's basically hashing something like every 10 bytes, and it's like a window that's sliding. And since hashes are uniform, if you have the same byte sequence multiple times in a file, the same hash will appear, right? So you just pick a number, say 20 or something like that, and say, I want to divide my file into 20 chunks. And you just pick that hash that appears 20 times. If a hash does that, or a hash that appears close to 20 times. And pick that as your delimiter. Because the cool thing about picking a hash as your delimiter is that if you insert something in the beginning, you're just shifting like all the next hashes because it's a sliding window. So that's really, really cool, because that means that we can kind of do these kind of different things on binary files. So in this example, let's say you had a file represented by this top box, and you ran it through the fingerprinter, and it found 5 chunks. If you then and like the first chunk is the blue one, the yellow one, etc., right? And these chunks are not necessarily the same size because it's using some content-defined delimiter. So the cool thing is, if we now insert the red part, we update the file and we insert the red part. If you run it through the same kind of delimiter, the same kind of chunker, since the content at the beginning hasn't changed, it will have the same natural delimiters, the same natural hashes, so the chunks will be the same. So it kind of guarantees that only the neighboring chunks will change. So in this example, only this chunk will change and only that chunk will change, which means that that's basically going to be our diff. So it's a really, really smart way of doing binary diffing. So we use that to make sure that if you share a data set and you only update like a small piece of it, even though it's a binary file or like a Linux container, we only share a small piece. So that's really, really awesome. Yeah, and Ross already talked about it. And then we use something like a BitTorrent ROM to kind of like share all these diffs. So that's pretty cool. So that's the Rabin thing is a really big difference from BitTorrenting. A really, really cool thing about using like an independent chunking strategy like Rabin is that I can get files from a third party. Like I could get a bunch of data from Faraz. And then if I get a bunch of similar data from somebody else, like you, the Rabin chunker can figure out that, you know, your data and Faraz's data share like 50% of it and not download that 50% from you again. So it's really cool because it doesn't need to be like a semantic relationship between your data and Faraz's data for this to work.
How do you treat that situation then? Do you copy simply the local version of the file?
Yeah, so right now we just copy the local version of the file. And this is something that's not working perfectly yet. We're still working on making it better, but it's actually pretty good already. And it's, I think I have a demo of it here. I can try to show why I shouldn't do this. So we call the low-level protocol we use is something that basically the 95% BitTorrent, 5% Rabin chunking, and this kind of thing we call Hyperdrive because it's a cool name and it kind of reminds me of space travel. So I made this browser build of it because it also runs in the browser. So hopefully I can show it here. So a really simple way usually of showing this is create a folder. So if I take a file, right, I should be able to, this is basically the same thing as for us, but just to have a good narrative, let's try it. So many open things here. So I can drag a file here and it does this fingerprinting thing, and it gives me this link I can share with somebody. So hopefully this works, or it's not blocked on this network or something like that. So I can share this with somebody else, and I can click it and read the file, right? So this is kind of like the same as for us for showing. But what happens if I just like copy this file 100 times? So this is a very simple way of showing that all these files are the same, so the review chunk will kind of like create the same copy of them. So let me reset this. It's very easy right now. Just have to remove the link and share like all these files. So actually hashing in the browser is kind of slow for some reason. I don't know why.
There's a way to make it faster.
There is? Oh, cool.
It's built. There's an API.
So I basically have like 80 copies of the same file here, and I have this really cool bug in my thing where up here there's a download speed measurement that it's actually not measuring the network speed, it's actually measuring the speed that it writes file to the file system. But that actually kind of shows you the deduplicator, like the thing, because if you share the same file twice, since the repeat chunker and all these things, it's smart enough to only fetch one file from the network, and then it figures out all these other files are the same because it has the same chunks. But the speed will show that it's just reading it from the file. So as you can see here, this thing I'm writing with I think it's things I'm downloading with 40 megabytes per second, which I'm clearly not. So that's what I meant by these kind of things. So it's not right now. It's really good at figuring out that files are the same. It's not perfect right now at figuring out that partial files are the same, but that's just like optimizations we're working on. There's no reason it shouldn't work. Cool. Fine slides. Next to that, in the DAT project, we're working on a Linux distribution that kind of encapsulates all this into a Linux distribution that allows you to run datasets as Docker containers, more or less. So imagine being able to mount a dataset inside a Linux VM with a build of the code that you're using to analyze the data. So if I make a build on my machine of some code, and it's like really horrible and it's really hard to build, I can package all binaries up with the data into a Linux container. I can share it to somebody who can run it, and reproduce the same results without having to download the entire container, because we're smart enough to just boot things partially and stuff like that. So we call that hypercore Linux, and it's really good to this. Oh yeah, and finally, since this is all peer-to-peer, it's kind of annoying dealing with these hashes all the time. It's kind of like not user-friendly. So we're also building a public registry for these hashes where you can get like a nice username, dataset name, kind of like GitHub. If you imagine Git is like that, and GitHub is like public bits. So it's going to be a public data tracker you can log into and search for datasets and get like a link that you can clone and put in your desktop app. Yeah, so we're already working with a bunch of cool scientists from a bunch of cool places to make this happen. If anybody in here has some feedback or want to help out, we always want to get more people on it. We have an RC channel on Freenode called DAT. We're DAT Project on Twitter. I'm Martin Touch on Twitter, so please tweet anything you have. If you want to try it out or want to get help setting them up. Also, I have stickers. Usually the most important thing about these things. They're pretty cool actually, and it's hexagons. It's actually my friend Max who standardized the hexagon, and there's a whole Japanese industry now about making hexagon stickers. So I kind of feel like in 5 years this is going to be our biggest impact to science. But I'm fine with that. Yeah.
Can you say
The canvas is not perfect, but
a few words about the versioning?
Yeah.
How's that working? Or is it already implemented? Or
So we're still iterating the versioning thing. We actually have something that's working, but we are kind of changing it because we don't feel it's perfect yet. So versioning. Okay. So first of all, sorry to be a little bit technical here, but if you have. Sorry?
that's why we're here.
Yeah, cool. You never know. So if you have like a data set, right, you run through our thing, you get like that hash up, right? Let's say you do a update to the data set. You run through the thing, you get another hash out. Using the repeat chunker and things I talked about, the system is already smart enough to only fetch the diff if you already fetched the previous version of it, right? So there's already a low-level notion of versioning. It's just not very user-friendly. So the only thing missing is having a feed of those hashes, basically, right? So you're, sorry?
Like you get log.
Yeah. So we're adding that, and it's set in a really trivial way. It's as simple as having like a public key that signs the hashes in a version feed, if that makes sense to you.
Okay.
Right. So basically the problem is trust, right? How do you, in a peer-to-peer sense, how do you subscribe to a feed of hashes, knowing that they all belong to the same source? So how do I get a bunch of hashes from you in the future? So if I just get your public key somehow, that could be through our data tracker, or you could just send it to me through a text message or something like that. I would just use this public key to somehow, using our network, find hashes, and you would just sign the hashes, and then...
That's to actually verify that they're actually from me and not someone else's changes.
Yeah, and then the cool thing about that is it still works in like a peer-to-peer sense. So that's coming. We want to get this thing working first. We want to get this stable first because, like I said, it's actually a very thin layer on top. We're probably just going to do a centralized edition of this also, where you can have an account on public bits, and you could like post a bunch of hashes to that. That's how it could work also. Yeah.
Presumably, if I want to have a use case that we're putting forward and actually use it to share encrypted data between a small number of people,
Yeah.
I could just encrypt the files and share them as encrypted blobs.
Yeah. I'm in no way a crypto expert. I'm more of a peer-to-peer expert, if I even want to call myself an expert, but I'm going to do it anyway. So I'm sure there are multiple ways by... Every time you do something with crypto, or call something secure, there are a bunch of people telling you it's not secure and it's not crypto. So I'm sure there are problems with that. So I'm not going to stay here tell you that it's fine, but it's probably
No, I
fine.
understand.
It's probably fine.
The rapid fingerprinting stuff if you encrypted the files?
I'm pretty sure that's not necessarily a good idea because it exposes data about the... It depends on which level you do the encryption, actually. So if you do the encryption before you do the wrapping thing, it's fine. But if you do the encryption, the wrapping thing won't really give you anything. So, because it's not
It's completely noise, yeah.
So there's a whole, I mean, like I said, I'm not an expert on that. Yeah.
You said you're much into peer-to-peer. How do you decide you want to go to a completely decentralized?
Yeah, it is already completely decentralized.
Yeah, decentralized, but how do you manage the not decentralized, I mean distributed?
So,
how does the PS fit into?
So this is, so I'm a pragmatist. I'm a huge pragmatist. So every time I can avoid doing something, I do it. And we do a really fun thing. Some people will probably call it a hack, but we just use the BitTorrent DHT for doing peer discovery. So basically, the BitTorrent DHT, if you're familiar with that, is just like a huge. It's probably the biggest decentralized network in the world. It's like really cool because it's so huge and it's bootstrapped. One of the hardest things about running DHT is bootstrapping it, like making sure there's enough peers for it to be actually decentralized and not just a thing that's running on your computer. So the way the BitTorrent DHT works is you should publish share one of a torrent file, and you say, I'm sharing this share one, right? And then somebody else can come in and say, I want to find somebody sharing this share one, and the DHT does a thing where it gives you some peers back, kind of like that. So what we do is we just share our hashes, so there's hopefully no collisions, and we just use the same technique, put them in the BitTorrent DHT. Because then we don't need to run our own DHT, we can just piggyback on their bootstrap DHT. And then at some point, hopefully when we're popular enough, we can roll out our own thing.
But you still need tracking servers where you can.
No.
Yeah.
So this is all you need to do peer discovery. You can still add tracking servers to do more centralized tracking. BitTorrent still does that. We also do that. We just use, I don't think that's in the repo yet. I just finished that yesterday here at the downstairs at a table. But it's using, basically just using DNS, kind of like what Bitcoin does, if you're not familiar with that, to find peers. So combination of DNS, the cool thing about DNS is that it works over UDP multicast also, so you can find it in the local network, and the BitTorrent DHT to find peers. So
Which was last?
BitTorrent, the BitTorrent DHT to find find peers. Yeah, it's a good question. Yeah.
Another question maybe about metadata.
Yeah.
Right now, the idea is basically just have the metadata in a separate file and share them together.
So good question. So how do you handle metadata? So I should have mentioned this, but on a very low level, like in our file sharing network, it's actually not relying on files. The network is just sharing blocks of binary data. So the way file sharing works is that it takes your files and it chunks them into binary chunks using the Ravine thing, and it puts them into a Merkle tree. And then it makes another Merkle tree of the file metadata, because the file actually has a lot of metadata. It has like a name, size, Unix data like mode, ownership, stuff like that. And it puts that into what we call a metadata feed. But there's no schema on this feed. You can put any metadata in there. So if you wanted to share data that's not a file, like any kind of metadata or any kind of structured data, if you took like a SQL dump and wanted to, we could put it into the same distribution model. We just don't have an API for it. But that's only because we don't want to do too many things at once. But we could easily add that. Yeah, good question. Yeah.
A similar question.
Yeah.
From the perspective of the user, as a data scientist.
Sure.
I'm not sure if I understood what the top level format of my project is. So I'm writing a paper, I have data.
Yeah.
Then I'm doing DAT share on my whole directory, or I put this on GitHub.
So the top level usage right now, and this is the result. We've been through like 4 major iterations, and every iteration involves us going to the partners we're working with, getting feedback on the API. And actually, in our first iterations, we had a lot of it was a lot more similar to Git than Dropbox, I would think. So you would add structured data into it. So you would pass your data and you would put it into something that's basically a database, and you would share using this. And that turned out to be too complicated for a lot of data scientist use cases. And so the feedback we got was that we just want to share CSV files and image files or like data files. So what you would do is, you can do it in multiple ways, but what you would do is you could either just make a folder on your hard drive with the data you wanted to share, like the big data, not big data in the buzzword, but like the files, the non-text stuff. And you would just share that folder, because that's the thing you don't want to put on GitHub because it's too big. And you would you get the hatchback, and then I would probably add a script file to my GitHub that's like download data.sh that will just do like that hash. So I wouldn't have to expose that to a user, if you know what I mean.
Yeah, so if I use it like this, it would be very similar to Git Annex or Git.
Yeah, but decentralized.
Yeah. Here Git is just always hash because you're just...
Yeah, exactly.
You just have a much nicer way of distributing the data.
Yeah. But it's like, so I have nothing against any of the large file sharing tools for Git, except that they're usually all centralized. Yeah. And usually all end up in some sort of payment wall. And payment, like in the sense that somebody has to pay for storage somehow. And that's fine. People got to make money. The only problem with that is in 20 years, whoever was paying for it probably stopped paying for it. And now I can't reproduce your data. So that to me is a big no-no. So that's why, we want to have if we can just get the same user experience as using GitMX, but having it be just decentralized, that would be amazing. So that's one way to do it.
Right now it seems even better than Linux already. You don't need this structure.
Yeah.
And also for this use case of data science, I would guess that not everybody produces their own large data sets. So I'm maybe having a large data set of all the countries and all the stuff. I don't want to host this.
Yeah, exactly. So that's one way of doing it. And the thing we want to head towards is the Linux container use case I talked about a little bit. So I have some fun demos I can link people if you're interested about with booting Docker containers using BitTorrent. So you can actually take a Docker container, and Docker container is actually pretty big because it's usually ends up being an entire Linux distro. And an entire Linux distro is usually around, let's say, a gigabyte. It's less than that. Let's just say a gigabyte. So that's a lot of data to move around. It's not something you can email. So what we tried to do was just take that gigabyte of data, put it in BitTorrent, because BitTorrent is decentralized, and then apply the same techniques as for us we're talking about, where we just like download what we need, and then expose that as a file system that would just take the Docker container, expose that as actual files in a file system, like every file in a Docker container, and then just run Linux inside of that. And the cool thing is that Linux, if you try to spawn a process inside that, the file system will kind of tell you what it needs to boot. Like it'll say, I need this shared library because whatever you're trying to run needs that. Try to read that, and our file system will just fetch that using BitTorrent. And the really cool thing about Docker containers and Linux containers is that they actually require very, very little data to boot because most of Linux is already running because it's a container. So if you want it to run node inside a container, the container might be a gigabyte, but the actual data needed to run it is megabytes, 2 or 3 megabytes. So we could take, so our idea is, like down the road, we want to take all your data, we want to take all your code, we want to put that in a Linux container. We want to share that using these tools, and we want to be able to boot that inside a VM that actually produces your paper or your analysis. And it's going to be super fast to boot because even though your entire thing might be 5 gigabytes worth of data and like all the binary dependencies you'll ever need, to actually run it, it's probably way less.
So in your end goal, like paper PDF also comes out of this container. This is my creative work and this is my data.
Yeah.
And in the end, it should be all in one.
Yeah, that's our opinion about it. But it's not. I'm not trying to force you to do that. I mean, one thing I learned doing this for a year now is I really respect the workflows that data scientists have because they're actually very advanced compared to what I would expect from non-computer people. So for us, it's very much about just building tools that help you enhance what you're already doing. So I think the Linux container thing is like the thing that will finally get us to really good reproducibility things, because then I won't try to build a code and it will fail anymore. It's like Docker, but just for science. And we'll have the distributed part of it also. So like, they won't have to sit there and wait for Docker to run, which takes forever. Yeah.
I was just sort of gaming scenarios in my head, and I was wondering whether it could be used to sort of get around the idea of uploading data onto a website. So if I want to share data quickly among a few friends, I could do this, but if I understand correctly, if I'm the first one to see it, I will have to be online.
So yeah, so this is a really cool thing. So that's like probably the biggest disadvantage with peer-to-peer systems you're talking about right there. So peer-to-peer system is not really valuable if you're the only peer.
Yeah.
So it's just like me to me. So we're a grant-funded project, which means that we don't have to make money, which is nice. It also means that it's hard for us to get money. But you know that if you're a scientist, you know that. But the cool thing is that we can get grant funding to run things like seeds. So we can get funding to run non-profit seeds out there that will basically just grab your data and host it for you for free. With the caveat that we might run out of grant money and like take it down, but it's distributed, so hopefully your stuff is popular enough that somebody else will pick it up.
So that was exactly my thought. Was there a function in your super easy to use tool where you don't host the data on your own system, but you push it to the Amazon cloud or to your local server and then point the
So we actually we have already small partnerships with Google and some Rackspace to get free resources online. So we're actually by you sharing something, it gets added to the BitTorrent DHT into our trackers once I merge this tracker thing I talked about. So we can actually detect that you push something, and then we'll just fetch it for you. And you might have, that's probably a way to opt out of that if you're concerned about what's it called, like anonymity, stuff like that.
If I can determine whether I upload it to the service you're providing, or whether I can just push it onto my own web server, my own address, or my own Amazon cloud account, then that would be ideal.
Yes, I completely. That's probably the main missing thing right now is the nice UX tools that tells you that your data is now synced to somebody else. which is a huge thing. I mean, it's probably way more important than all the peer-to-peer stuff I just talked about. Like that, having that small green icon that says like you're fine now, you can go away. Yeah. But it's not my job in the team, so I don't care about that. Yeah.
It sounds like you're proposing an idea of like what they call in BitTorrent like the web seed, like having an HTTP server that also has the data to use. That might be something to add.
Yeah. Actually, I'm not a big fan of web seeding. I'm a big fan of having permanent seeds. So I think web seeding is like a hack. A little bit.
Yeah, because people have a lot of HTTP servers lying around.
Yeah.
Or like
Yeah, It's like it's kind of like giving up a little bit, in my opinion.
Giving up.
Like you're realizing that the thing you build is not going to be popular enough for people to run actual seeds, so you just support your seed.
Yeah.
That's my opinion about it.
That's interesting, yeah.
That's everybody's opinion. Yeah. Cool. Did we? What time is it?
Oh, we're over yet.
Oh, cool.
By 12 minutes.
So yeah, I got stickers. I'm gonna put them up here. I think we only have this room for an hour, so I'll be around. For us, is also around. We should all talk to the IPFS people here. They're doing similar cool stuff with data distribution.
Why are you not using IPFS?
Why we're not using IPFS? So that's a good question. So the question is, why are we not using just IPFS for this? So there's a bunch of reasons. First of all, we want something that's very data specific, not generic for any kind of thing. Like we want to be able to take the we want to be able to, I need to phrase this correctly. So we want to be able to basically spend the last 10% of tuning things for data, and just data. Not generic file sharing, not generic, but just like for our use cases, because that's very important for us. So we want to support other protocols in there, because our thing might not be the best thing to share any kind of data. So if you go back to the version feed idea, where you have basically just like some way you can get updates to a feed somehow. We want to be able to say, oh, this file that's in the feed is now versioned by IPFS, and then fetches using that. Or this file is now versioned using WebTorrent and fetches like that. But we want our top level thing to be very specific to our use case, and like not do all the trade-offs necessary to be a very generic file system tool, if that makes sense.
Right.
So it's not, and by that I'm not saying there's anything wrong with IPFS at all. I'm just saying it's a way more generic protocol.
And there's a lot of optimizations you can make if you can make assumptions about your data.
Yeah. So by being able to control the last 10%, we can tune everything to our use case, but we still want to be able to shell out to whatever is good for other things.
But I think like something good to bring up is like because the data structure is pretty similar in terms of like.
It actually isn't anymore. It used to be.
It isn't anymore?
No, it's not a tag anymore.
Is that a tag anymore?
Now we're just talking like, you know what I'm talking about, I know what you're talking about.
Yeah, sorry. But
So,
yeah, I was just going to say that we.
Just like a disclaimer, I talk with these guys all the time on IRC, so we have like a lot of internal discussions.
Yeah.
So,
Okay, I was just like going to bring up the angle that we even had that like we keep like discussing.
yeah. No, so we're not using a tag anymore. So
You said in your presentation you were using tags.
we use a tree.
Middle tree.
All right.
But you only use the tree for actually doing the syncing stuff. It's just like a structure we built to do the sync. But our internal data structures are just append-only logs.
Oh.
Did anybody else get what we just talked about?
Sorry, you mean the tree with two E's or ID?
So
Like the data structure tree?
yeah, so that's a tree. That's a tree.
2 weeks, yeah.
Okay, this is turning into a very specific implementation. So my point is, we structure data by using something called, it's very simple, it's probably the most simple distributed structure is something called an append-only log. So an append-only log is just a list of data you can only append to. Very simple, it's very easy to sync. Probably the easiest data structures to sync. In order to be smart about syncing it, in order to know that, oh, half of this log I already have because I got it from Feroz from some other project, we built a tree on top of this. Because that allows us to do some smart decisions about if a hash matches half the list, and I already have that hash. I probably have that list because it's the same data. So that's why we use trees for our internal structures. That's like independent block. Very specific. Okay. But yeah, it's true. We used to do that.
Okay. Yeah. Okay. Yeah. Makes sense.
Yeah. We also want to support like, oh yeah, go ahead.
Yeah, just asking for those who arrived late, is your presentation somewhere?
I'll put it up somewhere on the internet. I can put it on IPFS because that seems to be the only thing working in this network.
Is there a URL, a central point of contact?
Yeah, so I don't know if this projector is still working, but we're thatdata.com. Should be that should be links to everything from that. There's also talks here, and if like. We want to get feedback from everybody, especially if you're a data scientist, because that's what our current grant is actually enabling us to work on. So please get involved. It's always fun for me to talk to non-coders because I learn a lot. I also learn a lot from coders, but especially from science because it's like such a new field for me.
Matisse, it looks like you're doing reviews.
Oh yeah, sorry.
If you guys have more questions, we'll be outside.
And remember to get a sticker.
I get this.